So, hi, my name is Jakub Jaruszewski. I am a DevOps engineer at PSNC, and we run, in my day-to-day job, we run multiple OKD cluster, which is an upstream of OpenShift on premises for multiple teams and projects, both internal and external. And our case was that we needed to provide Postgres solution that will be universal to everyone, and in a scenario when we cannot always synchronize the maintenance with other teams. So I will compare the available operators. So first of all, why do we even need them? Because we need to scale across the multiple projects that are used by multiple people. Some of these people do not have the cluster administrator privileges. So first question would be, of course, why do not deploy the Postgres directly? It's mainly because the operators provide the standardized approach. So we wanted to take away some of the responsibility on the teams that deploy the application itself, and manage the Postgres instances from the one place. And we tested 4 operators for that case. And one is Zalando Postgres operator, the PGO from Crunch Data, the Percona Postgres operator, and the Cloud Native PG. So for the agenda, first of all, we will go to through the basic architecture and concepts presented by each operator. And then I will go over the day-to-day HA operations, like managing the leader, failover, switchover, and what is supported by the operator directly. What can we achieve by doing some of the hacks? And then we'll go to backup and restore options. How good is the visibility of backups and restore are part of the capabilities themselves. Then we'll go through briefly through the observability. How does it integrate with existing solution? Does it provide centralized metrics or per instance metrics? And finally, the most important aspects, which will be how does each operator impact our day-to-day operations, because at the end we want a solution that works and that does not require much maintenance, and that's a solution that we can trust. So first of all, we'll start with an architecture for Percona and PGO. And they both share similar architecture, since the PGO is upstream for Percona. Percona is based on the PGO, so the main tools that manage the Postgres cluster here are the Patroni for the HA management and PG Backrest for backups. But these both operators have slightly different approach to backups, because the PGO schedules backups as the Kubernetes cron job, as the Kubernetes built-in mechanism. So its design is to, once the Postgres instance is started, it should be as independent from the operator itself as possible. So whether the operator crashes or can't keep up, then it does not affect the Postgres instance itself. But the Percona, on the other hand, has a separate resources for backups and restores, so which are triggered by the operator. So they have a little more dependence on the operator itself to trigger them, but at the same time, the visibility of the backups and restores is much better. And there's also different approach to extensions, where Percona allows to install external extensions. And probably the key feature for these operators for us was the ability to support multiple storage classes in a single cluster. Of course, you can do it in other operators by creating a standby, for example, but it is not the same as automatic failovers over to a different storage class. And then there was Zalando, which is unique in a sense that it is a very straightforward and simple to use because it makes some of the choices for us. And this is the Zalando Spilo stack. And there is a single stateful set deployment for the Postgres instances. Backup and restores are, of course, write-ahead log, but without PG backrest. They are managed by wall E or wall G. And it is a mature operator, but the development seems to be a little less active. For example, as of the date of this talk, the latest released version does not support Postgres 18. And then we have Cloud Native PG, which is probably the operator with biggest community, and it focuses solely on the Kubernetes native mechanisms. So there is no patroni, there is no PG backrest. Everything is managed by the operator itself. The switchover, the failover is also managed by the operator, and so it very heavily relies on the operator, which is like the critical path in this example. And it has a great documentation. It has support for CLI plugins, and it supports operator plugins in contrary to the others. So for the HA operator operations and upgrades, let me start from the two categories, because obviously we have the Patroni-based operators, which is the Zalando and the PGO and Percona, and Cloud Native, which does not use Patroni. So the PGO and Percona, each cluster has its own Patroni instance, and it's configured to use Kubernetes endpoints at the backend distributed mechanism as the Patroni requires. The Patroni, the failovers and switchovers can be triggered using the same resource that is used to create the cluster. So we have the one resource to manage that. And Percona has the advantage of supporting multiple Patroni versions. So even if you, for example, pick a different image and not exactly the one that is certified, it has a higher chances of working. And both support the automatic upgrades, major upgrades, of course, but both must be triggered explicitly. But Percona does a little more work for you, since you just need to create the Percona PG upgrade resource, and that's it. And in the PGO, you must also stop the cluster and allow the particular update by name using the annotation. And pausing and reconciliation of the cluster is supported natively by both. And then we have Zalando, which does not have a native support for manual switchover or leader election. Of course, you can achieve that, but you must be communicated to Patroni directly. It supports fully automatic major upgrades, which means that, for example, we might set a minimum Postgres version globally, and on each instance set the maintenance windows. And if the Postgres version is lower than the minimum Postgres version defined in the configuration, the operator will automatically do in place full upgrade. And it does support disabling the cluster, but it's done by scaling it to 0. So there's no separate feature like to pause the cluster. And that's okay, unless, for example, the cluster operators decide to set the minimum instances to 2, for example, to ensure that every cluster has the high availability, has at least 2 instances, then it is not possible to stop the cluster fully without stopping the operator. And the operator does not support stopping the reconciliation. So if there's a bug in the operator, and for example, you need some manual tweaking or to debug the particular case, and then you need to stop the operator, and you need to contact the team that administers the operator. And then we have Cloud Native PG, which uses the postmaster in each instance to run the Postgres, to have readiness and liveness probes for it. But the leader failover switchover mechanism is done by the operator. Switchover and failover are fully supported either by annotations or by using CLI plugin, which does the same thing. And of course, the pausing the reconciliation is supported too. And now for the backup and restore, we have the Percona and PGO, which are quite different, even though they use the same backend, because the PGO has a philosophy where everything is managed by one resource. So if you want to take one of backup, you set a flag and you set an unique annotation. But that is also means that the visibility of which backups are available at the moment and the status of the previous restores is not really visible. You need to go inside the PG backrest to check that directly. And on the Percona side, I have the separate resources, the Percona PG backup and the Percona PG restore, which are tied one-to-one to the job resources. So you need to be careful about your quota in the project, because the jobs are not deleted unless the backup itself is also deleted. And the cyclic backups here are triggered, as I said earlier, by an operator, and in the PGO they are triggered by the cron job that the operator creates. And then we have the Zalando, which pushes the physical and logical backups to the S3. And the S3 configuration is mostly global because you can set the default cluster wide, which can be a good thing, but in our case it was a no-go since we have different also external teams managing some projects. And Zalando only supports automatic backups. It does not support, at least from the operator side, it does not support the case where when we instruct the operator to take one-off backup. And the Cloud Native PG mainly supports the volume snapshots. It also supports wall and point-in-time restore, but you either have to use the deprecated Barman Cloud path or you have to install the Barman Cloud plugin. So by default, the per installation would support only the volume snapshots, and to have the point-in-time restore capabilities, you would need to have the plugin or use the deprecated path. And then we have the observability. So the PGO and Percona include their own stacks. So they are full end-to-end stacks, so you don't need to have you don't have dependencies on the other components in the cluster. So each stack has the central component, and in the cluster itself there is a metrics, a component that gathers the metrics and sends it to the central component. But there's a key difference because the Percona PMM can watch other databases too. For example, if you have a Percona operator for MySQL, then you can watch both Postgres and MySQL clusters in one place. And PMM requires a setup from the client side, meaning from the team that deploys the Postgres instance. So for example, if we are operator administrators and there is another team that is deploying the Postgres, we need to synchronize and provide them the key to the central component, and they need to properly configure the Postgres to send that metrics. While on the PGO, the PG meter can be enabled without the central component, and it actually just exposes the Prometheus metrics. So with addition of, if you have, for example, Prometheus operator with addition of resource like pod monitor, you can actually integrate it directly with Kubernetes native mechanisms. And in both cases, the status of the Postgres cluster can be monitored by status and conditions, although PGO has more of these conditions. And then there is Zalando and Cloud Native. This will be short because both expose Kubernetes native Prometheus metrics, so they do not provide an end-to-end solution like the PGO and Percona. But most companies already have some monitoring stacks, or for example, in our case, the OKD has a built-in Prometheus stack. So it is easier for these operators. It was easier for us to integrate the metrics into the system, which we already have. And then we have the most important part of the presentation, which is what is the day-to-day operations impact, what are the strengths of the each operator and the drawbacks. So we have the Percona, which has this unique feature, which is presented by the CR version property on the resource. So when you roll out the new version of the operator, the feature set is actually gated by the version set on the instance. So you do not need to synchronize with other teams. They can update in their own time, and there is no risk that some new feature will activate and break your setup. But there is still some reliance on the certified images, which are available in the documentation, but are not included in the operator default installation. So everyone that deploys the instance actually should check the CR version and should go to the documentation and should copy the references for the images to the instance because they are not provided by default. They can be set by the cluster administrators on the operator itself, but it is a functionality that comes from the upstream from the PGO, and it does not complement the CR version mechanisms good because you can only set the image per major version of Postgres, and you cannot do it per major version per CR version, as this would be the correct way to ensure that everything is compatible. The event visibility and error visibility could be better. Some errors are only visible in the operator logs and are not propagated to the resource itself. But the highlights is that it is able to survive the storage class outage. It has a very good visibility of the backups and restore. So you can easily check if the backup was made or what's the status of it. It has a great external extension support that no other operator has. So there's actually a documented and supported way to build any extension that is not included in the base image and use it. The documentation improved drastically over the years, and now I can say that the documentation is actually good. And I will say that is the best for on-premise deployments and for deployments where you have multiple teams and you do not want to put so much effort into synchronizing and communication between the teams. And then you have the PGO, which heavily relies on the certified images. which in contrast are included in the default installation. But the issue is that the images are not licensed under the permissive license. And the source for the images used to be open source, but it ceased to be. So of course, older version of the source for the images is available, but in reality, you either need to pay for the enterprise license, or you need to reverse engineer the operator because there's no list of requirements for an image to be compatible. And the same as previous one, it is able to survive storage class outage. In contrast, it has almost zero, the running cluster have almost zero reliance on the operator. So if something goes down, if the operator is overloaded, or suddenly if there is 100 Postgres instances to be reconciled, it should not affect the critical path. And one of its key features is that it supports auto PVC growth. So the risk of running low on storage space is significantly reduced. And I would say it's best for enterprise usage if you want to have this enterprise support. Then we have the Zalando, which main strength would be that is very simple to use and install. And that the cluster administrators can enforce some settings, some good defaults, and some constraints. So you only need to do that work once, and you do not need to have an ongoing effort to verify that every instance is configured correctly because it is asserted at the global level. But it has less development going on. It lacks some Kubernetes native mechanisms. So in some cases, you need to go inside the pod and run some commands and dig into the architecture of the image itself. It has good list of built-in extensions, but no support for external ones. You would need to rebuild the whole image for that. And so I would say it is best for internal usage when you have one team or a couple internal teams that are well communicated, and they all control the whole environment from the operator configuration to the configuration of the instances themselves. And then you have the cloud native PG, which has a very, very large community and very frequent upgrades. And it definitely has the most features, every feature like backups, storage configuration, streaming to other instances. It has multiple options on the cloud native PG, which is from one side, it's a good thing, but from the cluster administrator perspective, it takes considerably more effort to actually verify that all these combinations do work as intended. And in addition, it supports operator plugins. So if the operator is missing some functionality, you could actually write a fully supported plugin and you do not need to fork the operator. So I would say it's best for a diverse setup when you have multiple specialized cases and configurations, so you can set up everything like you need to. And that's it, basically. And thank you. Thank you. If you have any questions, do not hesitate to post them in the chat. And I hope you like it.